On your, so you guys have this already on your paper. I need you to write your name, geometry. Today's date is the 29th. And some of you guys have sent some things to me, scanned them without your name on them, and it's very difficult to send it back to you without a name, so make sure your name is on there. I'm asking you to include this on your fill-in-the-blank sheet right underneath, right before the vocabulary and after the section title. Marion, do you need? All right, so we have kind of left these properties. We touch on them every year in math, and then we kind of leave them alone and don't do anything with them except identify. So we are now going to start using them as justifications. So our addition property of equality, if A equals B and I add C to both sides, I still get to keep my equal sign. Subtraction property of equality, if A equals B and I subtract C from both sides, I get to keep my equal sign. Multiplication property, if I multiply C to both sides, I get to keep my equal sign. Division property. Now, two properties that are going to be, we're going to highlight is the reflexive property. Now, it may seem silly to say, obviously, A is equal to A, or 7 is equal to 7, or angle A is equal to angle A, but we're actually going to use that as a justification just to, in our different proofs. So, I know it seems silly, but just bear with me. The symmetric property says if I have A equals B, I can rewrite that in a different order, B equals A. My transitive property is a bit like the law of syllogism. If A equals B and B equals C, then we can cut out the middleman B and say A equals C. And then this is a property we use, it's the substitution property. If A is equal to B, then I can plug in B and anywhere A is in an expression. The next part. The distributive property. Oh my goodness, we've been using the distributive property for days and days. It says that if I have a number, or if I have an item being multiplied out in front of parentheses, every item inside the parentheses, as long as it's separated by a plus or a minus, gets multiplied by that value. So for this example, A gets multiplied by B, and A gets multiplied by C, and I keep the plus. It works if I have a minus as well. So if I have B minus C multiplied by A, that would be AB minus AC. The whole reason I've been asking you to show your work for the last, 5 years of your math career is so that when we get to this point in geometry, you are used to showing your work because you have to justify your steps. So problem number 1, justifying steps when solving an equation. What is the value of x to justify each step? So we are given that angle AOM and MOC are supplementary. That means they form a linear pair. So the measure of angle AOM plus the measure of angle MOC is equal to 180. That's the definition of supplementary angles. Definition of supplementary angles is that the measures add up to 180. So I'm going to take out the measure of AOM and replace it with 2x plus 30. I'm going to take out the measure of angle MOC and replace it with x. That is called substitution, when you take things out and you put stuff in for the same properties. All right, so I am going to get rid of my parentheses, which they've labeled as distributive property. I I would also accept simplify right here. I would also accept simplify. I would also accept combine like terms. When you're justifying your steps, so now you have to put words to the things we just did without an explanation. So now you're showing your work and you're justifying it. You're explaining what you're doing. All right. So we get 3 from 3x plus 30 equals 180 to 3x equals 150. What we're doing is we're subtracting 30 from each side. And that is the subtraction property of equality. And then I'm dividing both sides by 3. And that's the division property of equality. So we're taking it one more. Not only do you have to show each step to solving the equation, but then you have to, in words, tell me what you're doing, which application you're using, which property you're using to go from step to step. All right, so we're going to do the same thing for this got it problem. It says, what is the value of x? Justify each step. So the first thing we're going to do is they give us that AB bisects RAN. So we know that this angle is congruent to its buddy angle. So I want to make. So if we're given that line segment ray AB bisects RAN, then we can say angle RAB is congruent to which angle? BAN. What justification do we use? That's the definition of angle bisector. All right, so the next thing that we can say is that the measure of angle RAB is equal to the measure of angle BAN. The two measures are equal to each other because congruent angles have equal measure. Okay. The next step is we are going to substitute. So in place of RAB, I'm going to put X. And in place of BAN, I'm going to put 2X minus 75. And we do that because it's called substitution. All right, what do we do next to solve this? How about we subtract x from both sides, and that's going to be subtraction property of equality. And we get 0 equals x minus 75. And then we're going to add 75 to both sides. And we do that by the addition property of equality. we're there. We solve for x. So a little bit more complicated than just going with it. We have to give our justification. Okay, so let's see our properties of congruence. So for the reflexive property, says that line segment AB is congruent to line segment AB. Angle A is congruent to angle A. Symmetric property says if line segment AB is congruent to line segment CD, then you can write that with CD first. So line segment CD is congruent to line segment AB. And that works for the angles too. If angle A is congruent to angle B, then angle B is congruent to angle A. Transitive property says if angle AB is congruent to CD and CD is congruent to EF, then you can cut out the middleman and say AB is congruent to EF. And that works for the angles as well. If angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. And so on and so forth. All right, so using properties of equality and congruence, what is the name of the property of equality or congruence that justifies going from the first statement to the second statement? So to go from 2x plus 9 equals 19 to 2x equals 10, we would subtract 9 from both sides, and that's the subtraction property of equality. Angle O is congruent to angle W, and W is congruent to angle L. Then angle O is congruent to angle L. That's the transitive property. Measure of angle E is equal to measure of angle T. We write that as measure of angle T is equal to the measure of angle E. That's the symmetric property. All right, so let's do number 2 together. For parts A through C, what is the name of the property of equality or congruence that justifies going from the first to the second statement? So if we say AR is congruent to TY, and then flip those and say TY is congruent to AR, what property is that? Where we switch. It's a symmetric property. It's a symmetric property. If we go here, here's the test. We had 3 times the quantity x plus 5 equals 9. And we rewrite that as 3x plus 15 equals 9. What property allows us to go from the first statement to the second statement? I'll give you a hint. It's not any of these. And problem 2. What do you think, Morgan? Yeah, it's distributive. The distributive property allows me to distribute 3 to everything in the parentheses. All right, so if I have 1/4 x equals 7, and I bump that down to x equals 28, what property did I use to go from the first one to the second one? Multiplication property. We multiply both sides by 4. What property justifies the statement measure of angle R equals measure of angle R? It's the only one of our new ones that we haven't used yet. What is it when you just rewrite the property as it is? Do we need to go back and look at our properties? Please feel free. Out of these properties, which one is the angle equals the angle? We haven't used it yet as your hint. So that is the reflexive property. All right, so we're going to we've been our justifications. So the way we formalize it is called proof. So we're going to be proving stuff. And one way we're looking at it is with a 2-column proof. I personally love 2-column proofs because I love doing tables. Okay, so a proof is a convincing argument that uses deductive reasoning. In this chapter, we talked about deductive reasoning in prior lessons. A 2-column proof lists each statement on the left and the justification or the reason on the right. It's a great way to keep you organized and to go from step to step, and I prefer it. The first statement in a proof is usually what they give you. And the only time that's not true is if they give you a whole bunch of stuff. You don't list it all. Sometimes you don't use all of your given. The last statement that they give you should match the last statement you write. What you're trying to prove should be where you end. So if you're doing it right, then what they tell you to prove will end up on the last line. Given on the first line, what you're trying to prove on the last line. So even if you know nothing about proofs, you can at least have the first reason down there and the last reason down there. You get the bread in your sandwich, and then we fill it in with the rest. Okay, so we're going to use this little angle diagram to write a 2-column proof. If we're given that the measure of angle 1 is equal to the measure of angle 3, I should have that as my first statement, and the reasoning I have for using that is that, oh yeah, it was given to me. Thank you very much. From the geometry gods, they've gifted us with that information. And then, if you notice, the very last, the proof component should match the very last statement in our proof. All right, so as the better we get at proofs, our proof skills will improve the more proofs we see. And all we're going to do is we're going to follow the same format as the other proofs. So if you get lost, find a proof that looks kind of the same, latch onto it and try to plug in the same values. So at least your given and your end are the same, and the middle is kind of the same. All right, so if the measure of angle 1 is equal to the measure of angle 3, that's this and this, then we can say the measure of angle 2 is equal to the measure of angle 2. That's the reflexive property of equality. Think of the statement that you're equal to yourself. That's reflexive. All right, what do we call it when we add the same item to each side? I'll give you a hint. Property. It's right here, yeah. It's the addition property of equality. So we're going to add angle 2 to angle 1 and to angle 3, and because we do it to both sides of the equal sign, it stays equal. All right. We're going to say that the measure of angle 1 plus the measure of angle 2 is equal to AEC. That's AEC. And that's our friend, the angle addition postulate. Then we're going to say the measure of angle 3 and the measure of angle 2 is equal to DEB. Once again, that's the angle addition postulate. So we're going to use substitution. We're going to take out the measure of angle 1 plus the measure of angle 2 and put in measure of angle AEC. And we're going to take out measure of angle 3 plus the measure of angle 2 and put in measure of angle DEB. And that's called substitution property. All right, so now we're going to do this on our paper. Write a 2-column proof. We are given AB is congruent to CD. And we're going to prove that AC is congruent to BD. So the first thing we're going to do, I'm on my paper, so if you're going solo on this, you want to write your statements here and your reasons here. Nice little table. So what do we put for the first one? First is always given. So our given is AB is congruent to CD. Okay, that line AB is equal to line CD. And that's the definition of congruence. When you have two congruent line segments, that means the line segments are equal. All right, so number 3, if I say BC is equal to BC, that's the reflexive property. So we've got AB plus BC. So BC plus AB is equal to BC plus CD. And that's the addition property of equality because we're adding BC to both sides. Almost done. Then we can say we're going to substitute. We're going to take this little piece out. And we're going to replace it with, so BC and AB is going to be called AC. And then BC and CD is just going to be called BD. And what's the reasoning we use to do that? The segment addition postulate, we learned it earlier. Segment addition postulate. It says if I have two segments that are added together, then I can rewrite them as one segment with the first letter and the last letter. We're almost done. Those are gonna, if I have two line segments that are equal, I can say segment AC is congruent to segment BD. Because, oh, never. It is never a viable reasoning. You will never see that at the end of it. Okay, so, because equal line segments are congruent.